Okay, today we're going to talk about section 7.3, radical functions, part 2. We're going to look at the graphs of radical functions, specifically the square root of x and the cube root of x. So on the left-hand side is the parent function square root of x, and on the right-hand side is the parent function cube root of x. Notice some differences. So on the left-hand side, we cannot plug in any negative numbers. In the previous section, we talked about how we can't take the square root of any negative, so there's a domain restriction. So our domain is right here. Our domain starts at 0 and goes to infinity, and the range is your y values from 0 to infinity. My 4 points that I chose right here are nice points, meaning I picked 0, because that is our starting point, and then 3 perfect squares, 1, 4, and 9. On the right-hand side for g of x, the cube root, you can take the cube root of negative numbers, so negative 8 and negative 1. Notice I did not choose 0, 1, 4, and 9. I chose 0, 1, and 8 for the positive numbers because we want perfect cubes instead of perfect squares. So let's take a look at some examples. Before that, domain for g of x and range of g of x is all real numbers. So we write negative infinity, positive infinity here. All right, let's take a look at some examples. F of x is the square root of 5 minus 3x. Let's first find the domain. So we're going to set our radicand greater than or equal to 0. All right, so we solved 5 minus 3x greater than or equal to 0. Notice that when we have to divide by this negative 3 here, the sign flips, so as x is less than or equal to 5/3. So 5/3 is the biggest value of x. So your domain is negative infinity to 5/3. Plugging that back into your f of x function, 5/3 would result in the square root of 0, which is 0. That will be our first point. The other points we would like to choose is we want our radicand to be equal to perfect squares. So we are going to set 5 minus 3x equal to 1 and 5 minus 3x equal to 4. So instead of choosing random arbitrary numbers, what we are going to do is choose values of x that make the radicand equal to perfect squares. So in this case, for our radicand to be equal to 1, our x value is 4/3. So 4/3 is our input, would result in our square root being 1. The square root of 1 is 1. For our radicand to be equal to 4, that x value is 1/3. The square root of 4 is 2. So those are our 3 x values to plug in. Take a moment and graph those 3 points. Change your x-axis scale if you would like to make your points a little bit easier. I'm going to keep the scale just because that is what I have here. Notice my points based on color from these 3 points on the left here. So my graph will look like this. The domain, as we see, is what we have written here, negative infinity to 5/3. Our range. This y value will be either the smallest or largest value because that came from the x value from the endpoint of your domain. So in this case, 0 is the smallest number, so our range is going to be from 0 to infinity. Next problem. Square root function again, so we are going to set the radicand greater than or equal to 0 to find our domain. Our domain is negative 3 to infinity. For the points we are going to choose, we want the radicand to be equal to 0, 1, and 4. We have the value here that makes it equal to 0. So x equals negative 3 will be 1 point. We want the x plus 3 to equal 1 and x plus 3 to equal 4. Our 3 x values we are using for our inputs are negative 3, negative 2, and 1. Those are the values that would make the x plus 3 equal to 0, 1, and 4. However, we have a little bit extra stuff on the outside of our of a radical in our equation here that 4 minus. So we really have 4 minus the square root of 0, 4 minus the square root of 1, and 4 minus the square root of 2. So this output will be 4. 4 minus 1 is 3. 4, this was the square root of 4, excuse me. 4 minus the square root of 4 is 4 minus 2, which is 2. I plotted my 3 points. This one here is the starting point, and the other 2 are going down. So this graph looks like this. Our domain is -3 to infinity. Our range, that value up here is at the highest point of your graph, which has a y value of 4. So our range is from -infinity to 4. Now we are going to graph the cube root. Luckily, the radicand is just x, so the values we are going to input -8, -1, 0, 1, and 8. Our function has -2 plus the cube root, so we have -2 plus the cube root of -8. Evaluating them, -2 plus the cube root of -8 is -2 minus 2, which is -4. Following suit, the rest of them there. The work is written. Pause if you need to copy those down. And we are going to plot these on the graph. On the right is the graph of the 5 points. The domain and range of this function is all real numbers. All right, final example. Try this one on your own. Pick 3 nice points that would make our square root, the radicand, perfect squares. Since the radicand is -x, our domain is -infinity to 0. 3 values that I chose that are nice points, the perfect squares of 1 and 4, would result in your x values being -1 and -4 to get the radicand to be +1 and +4. The y values would be 0, 1, and 2. Plot these points. On the right is the graph of the function j of x. What is the range? The range is from 0 to infinity. This y value is still the smallest y value on your graph. And this is how you graph radical functions, specifically the square root and cube root functions. Thanks, guys.